In this video, you are going to learn how to solve systems of two linear equations by graphing. What do we mean by system of equation? A system of linear equations is formed by two or more linear equations that use the same variables. For example, on my right here, we have y equal x plus 4, y equal negative x plus 6. This is a system of equation because it is made up of two linear equations. And if you notice, the variables in these equations are the same based on the definition. Using this example on the screen, how can I solve the system of linear equations by graphing? So this is our system of equation, and this is what we call our Cartesian plane. We are going to graph this system on this Cartesian plane and then find the solution to the system. All right, so here we have y equals to 3x plus 5, y equals to 2x plus 4. In graphing an equation, we need two things here. These two equations are in what we call slope-intercept form. So we are going to need our y-intercept and we're going to need our slope. If your slope is not a fraction, if it's a whole number, put it over 1. Put the slope over 1. It will not change the value of the slope because we need our rise and we need our run in order to plot those points. So let us graph the first equation here. So our y-intercept for the first equation is positive 5. So positive 5 is right here. And remember, pay attention to your scale. So if you notice here, this scale, we are counting by 2. That means halfway between 2 and 0 is 1. And then here is going to be 3. And if here is 3, here is 4, here is going to be 5. So the first thing to do when graphing a slope-intercept form equation is to find your y-intercept. Once you find your y-intercept, you are going to use the slope to find other points on the graph. So our slope here is 3 or 3 over 1. So our Cartesian plane stop right here. If you notice, our slope here is positive 3. So instead of going up, I'm going to go down. I'm going to turn that positive 3 into a negative so I can find a point. So I'm going to go down 3 units on the y. So it's going to be 1, 2, 3. And then I'm going to run 1 unit to the left. So my first point is right here. Because remember now, if I'm going down, because remember here we have a positive 3 over positive 1. But since my Cartesian plane ends right here, my y values in here, I'm just going to go the opposite direction, meaning that I'm going to turn these into negative by going down, because I need part of my line down here. If I did have a larger Cartesian plane, I could go up, but I'm just going to use what I have. So as I said, I start at my y-intercept, which is positive 5. Then I went down 1, 2, 3. Then because it's a negative 1, I run 1 place to the left. Now I'm going to go down again. I need 1 more point. I mean, you can just have 2 points or any amount of points you want. All you need to do is to go down 3 and go to the left 1. It's going to be 1, 2, 3. Then I go to the left again. 1, 1, 2, 3. Then I run to the left. 1. Okay. So those are my plots. Those are my points. Now I am going to draw a straight line to connect those points. So I'm going to draw a straight line from there, going through all of those points. Okay, let me erase this line. All right, so that is my line, and that is the line for the equation. Let me just write the equation that represents that line. This line represents the equation y equals to 3x plus 5. So it is always good to label your line. It is always good to label your graph. So this line, or this equation, represents this line. Now I'm going to graph my other equation, y equals to 2x plus 4. So as we said before, if it's a whole number, if the slope is a whole number, all you need to do is to put it over 1, because 2 divided by 1 is 2. It will not change the value. So the y-intercept for this line is going to be positive 4. So I put 4 here. I put my first point here. I plot my first point here. Now, after plotting my point, if you notice, based on the Cartesian plane that we have here, we can't go up because we don't have any numbers, so I will have to just go down on my y-axis. So I'm going to change this positive to negative to show you that I'm going down. So I start at my y-intercept, which is positive 4. I'm going to go down 2, because remember, the numerator is my run and the denominator is the numerator is my rise and the denominator is my run. So with my rise, I go up or down on my y, and with my run, I go either left or right on my x. So I'm going to go down 2 units on my y. So it's 1, 2. Then I'm going to run to the left once. So again, when I run to the left once, I intersect right at this point here. But I'm going to use some more points, myself, to give me some more points so I can get a nice line. So I'm going to go down 1, 2, then I go over 1. I go down 1, 2, then I go over 1. I go down 1, 2, then I go over 1. I'm going to stop right here. I like to have enough points so I can get a good line on my graph. So now I am going to connect those points using a line. So I'm going to use a different color. Maybe I can use yellow. So I represent the two different graphs. So here I'm going to connect my points. Let me see if I can change the color to yellow. All right, so let me erase this one. All right. All right, so that is my graph. That is how you graph system of linear equation. Now that I have drawn my graph, I'm going to find my solution. So looking at this system of equation, if you look at the graph here, they intersect at one point right here. Just give me a moment. Let me redo this. Okay. So looking at this system now, what is my solution to this system? So the solution is anywhere these graphs meet at a point. So they meet at this point here. So I'm going to label this point. What is my coordinate for this point that they intersect? Is going to be when x is -1, y is 2. So this is the solution to this system of equation when x is -1, y is 2. And that is how you solve a system of linear equation, by graphing. And remember to label your lines. This line is y equals to 2x plus 4. This system of equation have one solution. And even before graphing, we can look at the equation and know how many solutions it has based on certain key things. For example, if you look at the slopes are different. So once the slopes are different, they have that system said to have one solution, meaning that they intersect at one point. Those two lines crosses each other at one point. And that point is when x is -1, y is 2. All right, we're going to look at another system of equation, how to graph it. All right, so we're going to look at how to graph another system of linear equations. So the example says, graph each system of equation and find the solution. So again, by looking at this equation, this system, we know that we have one solution. Why? If you look at the slope, both of them are different. So again, if you have an integer as your slope, you need to put that integer over 1, because in order for you to do your graph, you need to have a rise and you need to have a run. Because -3 divided by 1 is still -3, and +9 divided by 1 is still +9. It will not change the value. And again, of course, in order for us to draw this graph, we need to find our y-intercept. So I'm going to start with the first equation. So my y-intercept is -5 here. And remember, our y-intercept is where the line crosses the y-axis. So it's -5. Our slope is -3/1. So because our Cartesian plane in right here, our y-axis in right here, instead of me going down, I'm going to go up. So I'm going to flip the sign. So instead of me having negative, it's going to be +3 over -1. Because I need to have part of my line up on the Cartesian plane. So I'm going to go up 1, 2, 3. Then I'm going to run 1 to the left. Why? Because if you look at the original slope, my run was positive. So now that I flip the sign, it's become negative. And the -3 becomes positive. So I'm going to go up 1, 2, 3. Then I'm going to run 1 to the left. Again, go up 1, 2, 3. Then I'm going to run 1 to the left. So this is my points. Now I'm going to connect my points by using a straight line. So remember now, the slope is negative. It means that your line should be trending downwards. So this is my line for my first equation. Now I'm going to do the second one. So if you look at this graph, this equation, my y-intercept is 7. If you look at this graph, Cartesian plane here, I don't have a 7. But what you can do, you can just extend it a little bit so you see where your y-intercept is. So if here is 4, here is going to be 5, here is going to be 6, and 7 would be somewhere up here. So 7, so I'm going to go down 9, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So my 9 is right here. And if I go down 9, I am going to run 1 to the left. Sorry about that. So I went down 9 and then I run 1 to my left. So my point is right here. They intersect right at this point. So I don't have to go any further. I can just use a line to connect those two dots, those 2 points, because that's where the line intersect, and I don't have any more numbers on my Cartesian plane. Unless you have a larger Cartesian plane where you have more numbers, you can go ahead and plot more points if you want, if you need to. So I am going to use a red here to show. And remember, this line is positive. The slope is positive. So you need to go up. All right, so that is my graph. So if you notice, they meet at this point that they cross each other is my solution. So I have one solution to this system, which is when x is -1, y is -2. And that is how you graph, again, a system of linear equation. That is how you find the solution using graphing for a system of linear equation. And that is how you find the solution by graphing. And that is how you find the solution to a system of linear equation using a graph.